On the back page of our review, number 3 is a histogram, and it's going to ask me a lot of questions about it, okay? One of my personal favorite things to do anytime I have a histogram problem is I start out by labeling all the frequencies. What that means is how high every single bin was. So this one goes up to 3, 3, 8, 10. This one's at 5. It's a little tough to tell, but it's in between those. And then 2. Okay, you don't have to do that, but you know a lot of these questions they're going to ask you are going to have you tally up and add up several of these bins at one time. And so it's just easier to have them all labeled so you're not trying to fumble through that while doing a problem. A is a great question, probably one of my favorite questions on this test. Okay, it gets everybody. It says, how many trees are 75 feet tall? And a lot of people thinking about normal bar graphs, old school bar graphs, look at 75, they go up and they say 10. That's wrong. These are histograms. They have an entire interval of 70 to 75, or 74 really, 74 and a half or so. They have an entire interval in here that's filled up. Oh, I'm sorry, I was pointing to the wrong one, but 75 to 80. So we're looking at this bin, sorry. 75 to 80, they've got this entire interval that's filled up with 10. But we don't know if any of those are actually 75. Okay, they might have been all 74, or some of them 73 and 72. We don't know if any of those trees were actually 75. So there's no way to tell how many of those 10 trees were 75. It may be none, it might be all of them. We don't know. B moves on from there and actually asks you a question you can answer. It says how many trees are at least 80 feet tall. That means anything 80 or above. Well, I'm looking right here at this bin where 80 starts. And I need everything this direction, okay? Everything that direction. That includes this first bin, which is 5, has a frequency of 5, but it also includes that 2. So there were 7 trees that were at least 80 feet tall, okay? C says how many trees were measured. This is one of the times when it really comes in handy to have labeled your graph, or labeled your frequencies of your histograms, okay? Because now I can just add up all of these things. 3, 6, 14, 24, 29, 31. Add it all up, and there are 31 trees measured. Describe the distribution. I call this one symmetric, okay? You can see that if you draw the line over your data, it's pretty well distributed in the middle, or pretty well evenly distributed, sorry. We got 2 big bars in the middle, most of our data group there, 18 of our 31. On the left, we got 6. On the right, we got 7. It's pretty close. You could argue a skew one direction or the other, but I wouldn't, okay? I would just say this is nice symmetric data. If your answer to D was correct and you said symmetric, then that tells us exactly what we need for our measure of center, which our central tendency, which is E, and that is mean in this case. Anytime you use symmetric data, you use the mean. And anytime we use the mean, we also want to use the mad. Remember, whenever you're mad, you're mean. Or whenever you're mean, you're usually mad, you're mad. Okay? Mean and mad go together. They make sense. Okay? G, I've kind of already written an answer out here to the right of it. Ignore that, because G asks us what is the bin width. That just means how wide is every single bin. Well, all of these are 5 units wide. You can get real fancy and say 4.999, something like that, but just go with 5, okay? The bin width is 5 units across. H is a good final question. There's a typo in it, but you can still figure it out. How many trees are less than 70 feet tall? Less than 70 feet. So here's our cutoff right here at 70. And we want to know how many trees are less than that high. So we need everything to the left of it. Everything to the left means 6, 3 and 3. Please don't just count one of the bins. You've got to get everything less than 70. There's 2 different bins there, okay? They both have 3 trees. They total up to be 6. So number 4 is a bit of a tricky question, okay? It says, which is the best measure of center and spread for the data? Well, a lot of people are already sitting there thinking, well, some of these don't go together. From our problems, we know that mean and mad go together. So that means we can get rid of D, because D says mean and IQR. Mean and IQR never go together. Similarly, we know that median goes with IQR, which means A cannot be right. We're down to a 50-50 shot right here from the get-go. To get the rest of it, you have to actually know what this question's asking, and that's kind of tricky, okay? It's saying what's the best measure of center and spread. What it's really asking is this data symmetric or skewed? That's what it wants to know. From a cursory glance, it looks to me like it's going to be skewed, but I don't know. I think it might be skewed because I see that I've got a 13 and a 9, and the rest of my numbers are all in like the high 30s to mid to high 40s. So I'm thinking those two numbers might skew my data, but I want to be sure. What I know about symmetric data is that my mean and my median are equal. However, with skewed data, I know that my mean is less than my median, or that my mean is greater than my median. So that's really what it's asking you is, hey, is this skewed or symmetric? And you have to know this information in order to get that. Okay, so we hop over in our calculator and we type in this data set. Clear out whatever was in your old lists and type it in. We've got 46, 13, 42, 40, 39, 41. Okay, so that's all our data points. 10 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. Got them all in there. Quick scan to make sure they look pretty well correct, and they do. And now I'm going to go stat, calculate, and we're going to calculate our one variable statistics on list 1. Okay? What I'm looking for is a comparison between that mean and that median. I see that here for that data set, my mean is 36.2, but my median is 41.5. That's a pretty big difference there. There are almost a total of 5 units away from each other, or a difference of 5. So what that tells me is that we're using skewed data. Okay? We have skewed data. Well, anytime I have skewed data, I'm going to use that median, which means I'm going to use the IQR. Okay, that's this information, median and IQR, and mean and MAD are what let me eliminate 2 of the options from the beginning. Then I have to decide, was my data skewed or symmetric? Well, it was skewed, which means I want median and IQR. Okay, median and IQR. The last couple questions are a little bit more big picture questions. Number 5 says, list the order in which the measure of central tendency is affected most to least when there's an outlier added to a data set. Okay? Well, first off, you have to know what these measures of central tendency are. Okay? They are mean and median. You have to know that. It's just a knowledge you have to have, otherwise you don't even know what to write in these blanks. Okay? Then you just have to kind of think about what each of these numbers mean and how they get changed. We know that anytime we have skewed data, and skewed data often is because of outliers, like we saw in the last example, that skewed data takes our mean and it drags it with it. Mean and median want to sit there together. They want to be together right there in the middle, but skewed and outliers and skewed data drag that mean away. So outliers, and which create skewed data, cause our mean to get messed up. Think about median on the other hand. Median's pretty stoic. If we were trying to find the median of this data set from the last problem, the first thing we do is get rid of 9 and 47, our highest and lowest number, followed by 46 and 13, our highest, and I'm not marking off left and right, those just happen to be our highest and lowest numbers. 9 and 47 were our lowest and highest number, 13 and 46 were our next lowest and next highest. And you see that with median, we've already gotten rid of those outliers. So median is not affected by outliers very much, whereas mean is. In other words, our most affected would be our mean, and our least affected would be our median. For number 6, we follow along that same idea. It says our median is 3, and we want to know what the best guess for the mean would be. Well, our median is always right here in the middle. Okay, and so it wants to know what would that mean be. Well, that's skewed to the right means it's going to take our mean and it's going to drag it to the right. Well, dragging it to the right puts us somewhere around 4. You could argue 10, maybe, but I would say